Okay, good. So I'll start. I'll introduce myself. Okay, maybe. Hello, test. You can hear me, everybody? Okay, good. So hi everyone. My name is Nikhil Barthwal. My talk is cross-platform mobile applications development F Sharp. A little bit about me. I used to work with Microsoft long time back, and F Sharp was something that I got interested working in one of the garage projects in F Sharp. So interestingly enough, Microsoft actually doesn't really use a lot of F Sharp in their core products. It's mostly C Sharp. But Microsoft research is very much heavily on F Sharp, and a lot of side projects actually they do kind of in F Sharp. So Microsoft Garage was basically what some people would say as Google's 20%. So that's where I got interested in F Sharp. And later on, I moved to Jet. So Jet was like a e-commerce company acquired by Walmart, and they actually use F Sharp. So I was like a total F Sharp guy. Anyway. So the agenda I have today is I'm going to be using Xamarin platform. So I'll explain a little bit about Xamarin platform, why, what's the motivation, a bit of history. I'm assuming everybody knows F Sharp here. Okay, no, that's fine. I anticipated there will be some people who would not know F Sharp. So I have a little bit of slides on F Sharp also. Okay, yeah. So I mean, F Sharp. Some joke around. It's like camel.net kind of stuff. So it's not going to be any different. But I'll just kind of briefly talk about F Sharp now, and then I'll talk about compilation to different platforms. Okay. So let me start with Xamarin. What is Xamarin? I wouldn't exactly use the word framework. It's more like a platform. So what Xamarin Xamarin allows you, it's kind of a Mono or .NET framework for mobile devices, right? So you could write your app in .NET language and you can compile it, and I'll cover the aspect of how you compile it on Xamarin. Compile it and deploy it on the Xamarin platform. Curiously enough, if you go to Xamarin website, you see advertising and they say, well, you can use C# to compile the app and all those things. But the reality is, I don't know why they just say C#, but you can actually do F#. And C# and F# are the two official languages that Xamarin supports. I don't see a reason why you cannot do it in VB.NET, although I never heard of anyone doing it. But in theory, you should be able to, because it's usually if your code compiles to CLR at that point, it doesn't really make a difference what language you use. So my talk obviously covers about F#, but just to bear in mind, you can actually do whatever you want to do in C# also, or mix of both, either way. So why would you use Xamarin, right? What's so particular about Xamarin? Now, typically, if you were writing an app for iOS and Android and Windows Phone, if anybody still uses them, you would have like 3 different languages, right? With Xamarin, what you have is you have all of these native platform APIs wrapped as .NET libraries, right? So you could have a single code base, and with those single code base, you can actually compile and have this app running on all major platforms. And these apps, they perform natively. They have full device platform access, and you can have a native looking UI. So you don't really have a wrapper like something like Java does, which is like, it's a cross-platform UI, but hey, it's not native in the sense I can run a Java app and Windows app, and I know they're different, right? And in reality, what Xamarin actually does is Xamarin does 2 things, and I'll cover both of them separately. It has what is called as a Windows presentation framework. It ported that to Xamarin, and it calls it Xamarin Forms. So it's like a wrapper around UI, so all the native components are wrapped, so you can have the single code base. The problem with that is that there are peculiar characteristics of Android not present in iOS and vice versa, right? So at times you want to use specific iOS and Android capability. So it also provides you hook that those specific iOS and Android capabilities you can actually write in F#, right? And recompile it. Mind you, if you do that, then you're adding something like a platform specific code. So I'll cover that aspect in details later on, but the way your app would be is there will be a common component, right, which is going to be hopefully 80-90% of it. Most of your UI, like the basic functionality, can be common also. and then you would have specific components for your Windows Phone, iOS, and Android, right? And you basically, when you compile it on Android, it will pick the common component, and the Android component, when you pick on iOS, it will take the common component and iOS component, right? So in a way, you're not really losing anything. One of the problems with cross-platform is if you're trying to use a feature that is present in one platform and not present in another one, you actually can't do it. But with Xamarin, you could possibly do it at the cost of a little bit of complexity. So Xamarin actually started back as Mono project. So Mono was basically an open source version of .NET, and Mono was started by Miguel de Casa, who also, by the way, was the lead author of the Genome project, or GNOME project, I think that's how they pronounce it. And all the corporate stuff, Xamarin, they had Mono, then Novell acquired it, then there were some job cutbacks, so people, the original developers of Mono were back in the job market, and then Xamarin company came into existence, and they hired kind of all of these people back. And eventually Xamarin came into existence. First they released Xamarin Mac, which was basically a plugin for Mono Develop. Mono Develop was the open source Visual Studio IDE for Mono, which is something like an open source IDE that competes with Visual Studio, although I don't think it's that feature rich, but it's cross-platform. And eventually, Xamarin Studio was rebranded, and later on Microsoft acquired Xamarin. And when Microsoft acquired Xamarin, they actually open sourced everything. So now it's, most of it is open source. Earlier you have some parts that were open source, but for specific functionalities you needed an enterprise license for which you have to pay. Now pretty much everything is open source, and I should have probably added that in the slide. They rebranded Xamarin Studio as Visual Studio for Mac. So if you download Visual Studio on Mac, it's basically nothing but Xamarin Studio with just the label changed. So yeah, okay. So let's get back to F#. I'll actually, because there are some people in audience who don't know F#, I'll actually cover a little more. So this is the textbook definition of F#, right? F# is a mature, open source, cross-platform, functional first language. It's basically what it is it's a statically typed managed functional language, and it takes the core of OCaml and then puts up the object-oriented layer of C# and then calls it F#. There's actually a little bit of a history of how F# came into existence, and it has something to do with Haskell. So what happened was that Simon Peyton Jones, one of the lead, actually is like the inventor or co-inventor of Haskell, wanted to popularize Haskell. So they wanted Haskell to, to perform as fast as native language, to have easier adoption and so on, and he joined Microsoft Research. And Microsoft at that time was, that was the time when, I don't know the code name for it, but .NET, the earlier version of .NET, there was a code name for it. They were just trying to create project. Cool was C#, but anyhow. So they were trying to create a .NET platform for the reason that Java was picking up a lot in popularity, right? C++ was a beast. Nobody wants to go to C++. Java was picking up in popularity. So Microsoft wanted basically to counter Java. They wanted a managed platform. So they wanted to create .NET and, C#. They hired Anders Helsberg and C#, and that was an opportunity with Simon Peyton Jones thought that if I can port Haskell on this .NET, it would lower the barrier of adoption, and then people can basically write Haskell apps. And one of the problems with many functional languages is that the language may or may not be good or whatever. It's the the ecosystem that actually determines what you would use, right? So if you don't have really good third-party libraries, you are in a problem, and that's the reason why Scala is so popular, not because of the language Scala, but more because of just about everything you need. You have a package, a JVM library that you can readily use. So that was the original intention of F#. It was basically supposed to be Haskell for the .NET platform. Turns out they run into problems. And part of the reason was that .NET was more, it's mutable, it's object-oriented, so on. So Haskell doesn't really fit in. So they abandoned the project. They said, well, we can't do it with Haskell, so let's try something else. Let's try OCaml. So then they re-implemented OCaml into OCaml.NET, and that was what we call as F# today. So F#, when it started, it was pretty much a port of OCaml and .NET, Over the years, F# has actually expanded quite a lot, and it has borrowed a feature. So now if you look at F# today versus OCaml, there are a lot of things in OCaml. I don't know for why, but sort of OCaml development of new features kind of stopped after 2008, 2009, whereas in F# it actually continued quite a lot, and there's a very big community. And this is how F# actually came into existence, right? So for somebody who's coming from ML, OCaml background, a lot of things that you see in F# is going to be like, it's going to be something very familiar. There are things that offers F# adds. The object-oriented part of the language actually is more similar to C#, but the functional part of it is still very close to OCaml. So like any other language, F# supports higher order functions. You can combine functions. You have algebraic data types that they call as discriminated unions. It encourages pure programming, and it has support for pattern matching. Now, the tricky part of it is encourages pure programming. So one of the, I don't know if this is more like an opinion thing, but pure programming to me is a double-edged sword. Like sometimes if I'm writing Haskell code and I have a lot of I/O, I have to wrap it in monad, it kind of becomes a pain. It's not that easy. So the idea is that, at times where you need to do I/O, you need side effects, that's fine. The code should be written in such a way that put it as much pure as possible, but have a room for impurity as and when you need it. That was the design philosophy. So it encourages pure programming, but it doesn't want to constrain you that badly like Haskell that you just have to write pure code. You can't write impure code. That obviously has a downside. And the downside is that you can abuse that, right? You can potentially write a lot of impure code in F#, which could basically be object-oriented code written in a functional language. And you see that all the time happening with Scala, right? So, and I was very shocked when vast majority of Scala developers that I've met for some reason, maybe I haven't met good developers, I don't know, you basically use Scala for object-oriented. If you look at the code, it's full of vars, all the mutating states. And you know what? Kafka was written in Scala, and I was shocked to find out that it was something as popular and as standard as Kafka was written in a way that was like, I don't know why they wrote Scala. It was like an object-oriented code written in Scala. So you want to give people the room to have the flexibility of having side effects, but at the same time, you don't want people to abuse that. So the way you do it is you design features that allow you to use side effect, but you make it hard for them. So they have to fight with the language to actually use it. So they will fight when they need it, but not fight when they don't need it, right? Scala, when you look at all the languages as a spectrum, right? Object-oriented language on one side and functional language on another side, Haskell obviously is a purely functional language. And if you look at something like C#, it's not really, it's predominantly an object-oriented language, but there are a lot of functional features, right? So I see languages as a spectrum, right, of maybe Haskell on one end, symbol of purity, and something like, I don't know, Java, although Java 8, Java 9 is somewhat functional, they support Lambda functions on another end. And C# would be like 20% functional, 80% object-oriented. Scala stands in the middle, which is like a 50-50, right? It's 50% object-oriented, 50% functional. F# would go on the side of 25% object-oriented, 75% functional. So it's functional, but it's not a pure functional. And if you look at the definition, it says functional first programming language. And that's actually a very, they use the word functional first, but they did not say functional because they wanted to clearly differentiate. This is not a pure functional language. It encourages functional programming, but is not a pure functional language. We would have some code samples. I obviously can't go into details of F# code. So there are some resources. Expert F# is the one I recommend. It's actually written by Don Syme, the inventor of F#. F# for C#, if you're coming from C# background. If you're new to functional programming, maybe beginners F#.
There's another great book called F# Deep Dive. Meaning it was released about 3-4 years ago. And good in a way, it's collection of use cases.
Okay.
Or study cases. where people from different companies describe what they use F sharp for and what their successful payload stories are.
Who was the author of that book?
It's just collection of stories, but Tomasz Petriček, he was the editor of it.
Okay. Yeah, I've seen that book. I haven't read it. But yeah, actually, even Scott Walshin has this website, right? F Sharp for Fun and Profit. Yeah, that's right. So he actually compiled it as a book also. So that's
2,000 pages long.
yeah. I
Try
mean,
to read it.
no, actually, at JET they use that as boot camp. Obviously, they would not make you go through 2,000 pages, right? They selectively select the part. But I mean, it's good in the sense that you can select what parts you want to read and what parts you don't want to read. So moving on, Xamarin and F Sharp, right? So why write code for Xamarin and F Sharp, why not in C Sharp? Turns out that this is a really good match for each other because functional languages, and we all know, are very productive, code correctness because of the type system. And there are a lot of good stuff about functional programming, and Xamarin also has a good stuff like, you can have single source for platforms, native performance, native API. So by combining the two, you kind of have best of both worlds. And I actually added dependency injection here. And one might wonder why specifically I did dependency injection. I mean, obviously, dependency injection in functional languages is very simple because basically you can pass, because function is like a first class citizen, you can just pass the function. Why dependency injection is important is because when you're doing cross-platform, right, you want to have a functionality which the way it works is different on Android than iOS. So you can pass that functions for your Android, you can pass it for like Android corresponding function. For iOS, you can pass it. So it allows you to clearly differentiate between what is your core logic of your business logic of your app from the platform specific nuances. That's why dependency injection in this context actually is a very important thing. So this is how Xamarin platform would look like, right? You obviously have the specifics of platform, iOS, Android, Windows Phone. Windows Phone is .NET, that's why you actually don't need any specific bindings. And then Xamarin iOS and Xamarin Android wraps the specific binding. And then you have Xamarin Form, which basically is like a general purpose UI. And in real life, you actually would kind of use both. You would use both Xamarin Forms and iOS, right? So this is not exclusive. And on top of it, you have the whole Xamarin API. So for setup, you basically, from the iOS side, you just need Xcode and Xcode command lines and Xamarin iOS. On the Java side, you would use Android SDK Java and Xamarin Android, and you need mono runtime for Mac or Linux. I haven't heard anyone actually using Linux for app development, but I suppose not for iOS, but Android it should be possible. iOS definitely you won't be able to do it because it's a requirement that you have to have a Mac platform. Which is funny because a lot of companies that actually they do the apps, right? They have all the CI/CD and Linux servers in the cloud, but since you can't virtualize a Mac, they would basically have a physical Mac boxes connected to their virtual Jenkins instances just because of the fact that you can't build iOS apps on Linux and Windows, right? Lately, I think Microsoft started providing you with virtual Mac boxes, so that's not that of a problem anymore. I don't know how, if anybody uses it. It's like 6 months ago they started it, but anyhow. So cross-platform project organization, right? How would you have it? You obviously want to have a common component and you want to have like a separate component. How do you differentiate with it? So there are different ways of doing it. So you can have two projects and you can have just a file linked to common files. You can have a cloned project, so which is kind of messy because what you have is you have two separate projects referencing the same set of files, and then you could have something like a shared project, right? So I have an iOS project and I have an Android project, and the reference is a shared project, which is relatively better than the first two approach. But for particularly Xamarin, it provides what is called as a portable class libraries. Portable class libraries, basically you can import it in any project. It's not a separate project, but like a subset of the project. So that way, you can basically have one project for with all the platform targets that you have, And you do have preprocessor directives, right? And obviously you can use dependency injection. So you have preprocessors that whether you're compiling for Android or you're compiling for iOS, so you could do if Android, then use this code, else if iOS, use this code. All that features are there. So Xamarin Forms, right? So Xamarin Forms basically uses MVVM model. I'm going to talk about MVVM model a little later. So it has like a MVVM model, and there's a shared code with Xamarin Forms, and then you have the specific what is called as a custom renderer. So custom renderer is basically the iOS specific or the Android specific API that is wrapped. So if you want to use a feature that is only available in that particular platform, you could do that with custom renderer, and then you can have some part of it with Xamarin Forms. Usually you would have both. Usually you would basically, a real life application would look like I'll have my common UI component in Xamarin Form because I want to keep as much code as possible in the shared one, because that's really what my goal is, that I don't want code duplication or functionality duplication, and only the stuff that I cannot keep in shared, I actually would use something like a custom renderer. So the goal is to maximize the shared component of it. Okay, so it uses MVVM model as opposed to MVC model. Part of the reason is because MVC model ties very much, like the view is very much tied to the platform, whereas in here you can't have it. So you basically would have a view model, right, with view that is platform specific, and then you have a data binding and, you know, any notified property change and so on, and obviously the model stays as it is. So what MVVM model does is it facilitates the separation of development of GUI from the logic, and view model becomes kind of a model converter for exposing the data. There's actually a better model for this. I'm going to talk about this, but MVVM model, and this came from Windows presentation framework WPF. Did I miss? Okay. So lately Elm is actually very popular, and Elm, they actually have a new form, Elm Xamarin Forms. I'll have like a website on this and I'll go through it later on, but just a quick, it actually uses a variation of the model view update paradigm that actually Elm uses, right? So you don't really have to write a view model class. What you have is basically a model, and update will pass messages to update that model, and view is nothing but essentially a projection of the model, or in Haskell terminology, it would be something like, you know, you have a type class and then you have a show. So you can put a show to that object and you know how to render it on the screen. So here, a view is basically a mechanism to render the model in an HTML. So there was an inspiration Don Syme had of why he wants to use this model, and basically a lot of people were liking Elm and React and so on. So he basically wanted to bring this kind of programming model to Xamarin and F#. And this actually is a website where you can actually go, and he has all this discussion. GitHub used to be independent from Microsoft. It's no longer is, fairly recent development. Okay, so this is the model view update pattern, right? So you have the model, it renders a view, and then you would pass a message. So you would interact with that view, and that generates the update, it generates the model, right? So I've had this on the right side. I also have like a, I think it's a UML diagram that you can have initial model, and then you render that view, and as the messages pass, you keep like updating the model, and the model will render the view, and that this is the model view pattern, right? The standard how model view pattern works. So an F# implementation of model view pattern. So it's a very simple code. You know, you have a message, in this case just one pressed, and then you have a model that basically captures a state, which is the button is pressed bool, and then you will have like a initial state and then update. So each time the message happens, you basically update it with press, and then you have a view that takes a label and says I'm pressed or press me, you know, a very simple implementation of a model view update. And then you have the runner that ties it down. Okay, so far so good. We have been talking about F sharp and we have been talking about Xamarin and so on. But what if you want to use Objective C or Java for your actual app? There is a way to do it. There is a way to tie up your app and use Objective C or Java. Mind you, if you do that, it's like Java also has like a native interface. You can actually use call native code from a managed Java code, but it has a downside that you're sacrificing portability. So you could do that, but it comes at an extra cost of I wouldn't say it sacrifices portability, but obviously the more platform specific nuances you add, the more wiring you have to do, because it will put more bindings, and it just makes your code a little bit messy. So you would have to separate, okay, I'm going to use the platform specific code in iOS and Objective-C goes there if there's a platform specific library. Generally, you want to avoid this thing, and Xamarin would pretty much give you everything you need, but for whatever reason you want, there's a facility that you can actually use raw Objective-C. I don't know if they support Swift though. Maybe they do. But their documentation said they actually support Objective-C and Java. So developers can see bindings from Objective-C. They have a tool called Objective Sharpie, which actually can process these and expose this as C# bindings. And the similar thing in Java, they have Java to C# binding is one-on-one, right? Because it's a class with all the method and you have metadata that Java library exposes. So Xamarin can use it. So the Android, on the Android side, binding to native code in Java is easy. On the iOS side, you can run into difficulties. There's actually a website also that you can upload the binary and it tells you what like a platform compatibility factor. I'll see if I have the link to that website. iOS does present some nuances. I'm going to talk about it. Part of the reason is that it does not follow the JIT model. Okay, so compilation with Android. How does the compilation actually works? So what happens is that when you compile your code, it actually takes that mono platform and it takes a subset of it, the one you're using, and it uses static analysis to determine what are the components. So you don't want the entire mono platform, right? And at runtime, this code is just in time compiled, pretty much like Java would do to the native code. So that's how the Android compilation works. Unfortunately, iOS is not that simple. And the reason why iOS is not that simple is because Apple does not allow JITting. There's no dynamically generated code. So for iOS, you actually have to do ahead of time compilation, right? So it compiles it ahead of time, which has its own advantages. Like you don't really have a shortened startup time and potentially better performance. I don't think performance would really matter that much after the initial startup, but it puts a certain limitation. And the limitation it does is that runtime features like runtime type identification you can't do, because ahead of time compiler needs all that type information to compile during the compilation stage. So if you write code which is very generic, that the compiler cannot infer type from it, that code will not compile on iOS. It's usually not a problem, not in 99% of the cases, but there is 1% chance that you run into that problem. And this is why Objective Sharpie and all their tools, they kind of determine what your what's your compatibility factor with iOS. But this problem is very specific to iOS. It's not really on the Android side. So unit testing, okay. Unit testing. So this is actually pretty generic about unit testing F# code. It isn't really anything specific. So you have FS unit, right, which is really basically taking a functional paradigm and it wraps over N unit, X unit, and all the standard MS test. MS test is the Microsoft test framework that comes with Visual Studio. Pretty basic, but it's good enough for most of the purposes. The good thing is you don't really have to do anything because it's inbuilt in it, right? Then you have more sophisticated N unit and X unit. And then there is a FS check, which is basically Haskell's quick check port to F#. I know there was a talk on property-based testing. So you do have that facility in F#. I don't really think it's as sophisticated as quick check, but it still does a pretty good job. FYI, quick check. I mean, there's a commercial version of quick check. What is it called? Cubic. That actually is much better. I had a talk with John Hughes. He was one of the implementers of quick check, and he was telling me that they had a lot of features on Cubic, but that's commercial. So yeah, so F# has a port for quick check. They call it FS check, property based testing, standard stuff. So that's an example. You have a test fixture, you have a test. In this example, I'm not showing, probably I should, but there's obviously some of like test setup and test tear down. So you will have a class which will set up, you have a test suite that runs a number of tests, and then you have a tear down in case you need it.
You know what's a good thing about F# unit test? You can name your method with double backtick.
Yeah.
In plain English, explaining what your test does.
Yeah. So F# has this, that you can actually backtick, and that's like an escape character, so you can add spaces. So you can actually write like one sentence describing what your unit test is, and when you look at your Visual Studio GUI, it actually would determines like this is the test that failed, passed, and all those things. So it's purely from a documentation purpose, but it's actually good. Yeah. So deploying and testing on devices. Obviously, your code compiles, you have simulators that can run, you have simulators in the cloud and all those things, but always, you want to test that code on actual devices. So, sorry.
Did you ever work with the camera stuff? Is it like really working?
Not really.
Okay. Because I have 2 apps that I can try at Dr.
I mean, you could do it. I don't see a problem why you cannot use camera and so on. You obviously can't do it on an emulator because you don't have a camera on an emulator, right? And this is where this stuff comes in, that you actually want to test it on an actual device. And I think Apple has a program, right? You can sign up for Apple Developer, and then you can create those test apps that you can download. So one of the things that emulator does is that performance is something that you can't test on the simulator, right? So there you need actual devices. And obviously, like you pointed out, GPS, camera, and all those things, these are present in real devices. For iOS particularly, maybe to some extent, Android also. See, I talked about when you compile, you actually take a subset of the mono framework, and that's determined statically. And static analysis works 99.99% of the time, but not 100% of the time. So you could run into a situation where you might be using, like, you're using some complicated inheritance models. You take all the abstract classes and some of the base classes, but the static analysis did not determine that there was one particular class that you could be using and it wasn't included. So since when you emulate the code on your machine, the linker does not use static analysis. It takes the entire framework. But when you actually put it on device, it actually takes a subset of the framework. So to make sure you have taken everything that you need and you have not forgotten, it's very important for you to test it in actual devices. And this is particularly true for iOS, although for Android also you can run into problems. So pretty much the end, I have a summary. So Xamarin platform, right? I can use like to form cross-platform mobile apps in F# from a single code base. Forms can be used for cross-platform UI. It's very important to test your apps in actual devices. Then compilation scheme is a little different. For Android, you have like just-in-time compile, whereas iOS uses AOS. And then you have bindings for native code. Now, I do have some resources, and I do want to point out this one. So this is the main Xamarin homepage. Okay, so Xamarin documentation. Now, funny that they actually say C# everywhere, but like I said, you actually can use F#. If I had my Mac, I would have actually showed you. Apologies. Very good starting point. F# samples for Xamarin. So it talks about how to create an iOS app, Mac, Xamarin Forms, everything. So you could actually use, there's a book, the Xamarin Forms book was written by Charles Petzold, who actually wrote the book for C#. He's a very famous guy in the Microsoft community, but there's a translation to F#. So you actually have, pretty much you can actually go to the GitHub pages and you can see the F# translation for the code. So that's how you create cross-platform code. So this is all F# stuff. It's actually there's some C# also, surprisingly. Okay, there's C#. Actually, I don't know why, but this is weird.
Check maybe there is a different range for F#. That's how I usually do.
Okay, so let's actually see. No, I don't know.
No.
This is GH pages. I think that's where probably.
Pages is for website.
Yeah, but it actually was a translation of. So this is actually the original stuff. Okay, hold on. Let me go back. Samples have been. Achha, it says number of samples. It probably didn't port all of them. That's what my guess is. So let's actually see. Okay, even this is C#.
But you checking UWP, I think your F# does not support it for UWP.
Okay, I could go
Check iOS.
Well, app delegate. I don't know. Okay, I have no idea why this is the way it is. It should say, but anyhow. Okay. Anyhow, so we can just look at. So let's actually use scene kit developer.xamarin. So it's going to Xamarin. So it's probably using F# here. Okay. So this is the C# sample. Okay. They say F#, but okay, this is it. That sample shows how to create by using. Okay, so this is it. Yeah, this is what you basically want to look at. And sample uses this one and is using n is written in F#. Composing. I think that's the browse code is what we are going to look at. And this should be, please tell me it's F#. It is F#. Yeah, so you have sample code here. That's basically, this is all F# and it kind of ports that C# code. So you could see all the F# code very similar to ML, right? I think this is the UI part. So UI library, yeah, UI part would have state. I think, yeah, this is mostly UI. So I'm not even F#. Like if you do F# on like Windows, the UI part of it, right? You would be assigning a lot of properties because inherently UI is a very state based approach, right? So that doesn't really surprise me here. But anyway, they have, yeah. So they do have, this is the UI part of it, setting the camera's targets up, and they have some camera code also. So let me actually look at it. On my laptop, I have like a lot of stuff set up. I apologize that I don't have my laptop with me. It's pretty unfortunate, although I never realized that iPad would do a job pretty good, but sure. iOS samples, I think. Let me actually go to iOS sample and see what I have. So I have several of these samples. I don't think all of them are in F#. Many of them would probably be in C#. But yeah, most of them are probably in C#. But nevertheless, they actually give you good examples of how you can, how the .NET API is wrapped around native code. So if you know F# and you could see the C# code, how they're using it, you can pretty much easily translate to F#. UI is obviously the part that gets tricky and that needs translation. Your core business logic, you can, it's just F#. At that point, you're not using Xamarin. So it really doesn't really matter. You could just test it on your local desktop, your core logic. So yeah, anyway, yeah, so these are the resources Xamarin have formed. This is something that I want to, so this is where the model view update stuff comes from. So that was that code example I showed you. Dynamic views creation using F# Xamarin. So you have that stuff. Yeah, so pretty much all of F#, good examples for F#. And last but not the least, if you have any questions or any help now or in future, there's my contact information. Happy to answer, take any questions.